All right. So we have this situation where we want to find out if our point, if a test point, I'm going to actually draw that here, is on in front of a plane or behind a plane. But how do we do that? How to tell if a point is on one side of a plane or another? So that's an interesting question. And if you're not good at geometry, you might go, oh my god, that's kind of weird. It turns out it's really easy to do. And the way that we do it is we start with the equation of a plane. Now, there's a bunch of ways to define a plane, of course. 2 points define a line, 3 points define a plane. Another way to define a plane is you have a point and a normal. Any point in space plus any normal defines a plane, because the plane is every point that's collinear with the base point and orthogonal to your normal. Okay, bam. So you can actually, with a point and a normal, you can define a plane. The normal defines the orientation of the plane, and the point defines the offset. All right, so given a point on the plane that you want to test against, let's call that x0, y0, z0. Okay, great. And a normal to the plane, which we'll call A, B, C, right? Those are my three normal coordinates. Let's call them A, B, and C. Then we can use that to generate the equation of a plane. So the equation of the plane is actually A, which is again my normal x coordinate. X is a point we're testing. B, Y is a point we're testing. C, Z is a point we're testing. Plus D equals 0. So A, B, and C are my normal indices. X, Y, and Z are the point I'm testing. And now I'll show you where the other, our x0 comes in. D is actually defined as being minus A, x0, plus B, y0, plus C, z0, where x0, y0, and z0 is whatever point you used on your plane to define the plane. Great. So all that we do with this equation then is we plug a test point in. So we plug test point in and we solve, okay? I should probably highlight this. This A, B, and C, these are our normal, and then our point is this thing here. So it's really, really a simple equation. So we test a point in here. We test any point in space. We have an x, y, and a z. We put it into this equation, and we'll get a number out of it. We'll calculate. We'll get a number. If it's 0, okay, that's the definition of the plane. It's on the plane. If it's bigger than 0, it's in front of the plane. And again, I'm going to say, as you know, planes don't really have fronts and backs, but they do if you give them a normal. I'm going to say this is in relation to the normal, right? So it's the same direction as the normal. If it's less than 0, it's on the other side or behind the plane. So you can actually test very, very quickly and very easily whether a point is on a plane with a few multiplications in addition. It's not hard. You can do that, and you can test whether your point as part of your geometry is on that side of the frustum or not. So we can generate these equations for our view volume very easily. Right? There's a lot of ways you can do it, but an easy way is you just use your corners of the view volume as points for the equation, and then you can use the cross product to generate normals. Okay, that's that simple. So you do that for each plane, and then I can apply this test to my view volume planes, all 6 of them. Test all 6 planes. So you can imagine making a function here. It's not hard. Point is inside if it's inside plane 1 and plane 2 and plane 3 and plane 4 and plane 5 and plane 6. If it's outside any of those, then it's not inside this view volume, right? Maybe it's out here. If it's, oh, that's a delay. If it's out here, if it's out here, then it'll be inside all of the planes except this last one right there, right? Let's undo that. Okay. Cool. So that's it. It's really simple to test whether or not a point is inside or not. Now you might be thinking, that's actually a lot of work, isn't it? I have to do 6 planes to test 1 point. Well, wait a second. I'm testing 3 points for a triangle, so 3 times all this work just to test a triangle. Maybe there's a faster way. And it turns out there is, but we'll get to it in a bit. But this is really important because it helps us in really specific situations that I'll come right back to.